Question 16, an athlete is running in a race. The diagram shows a speed time graph for the athlete. Work out an estimate for the acceleration of this athlete at 3 seconds. Now, the acceleration on a speed time graph is the gradient of the function. So we want to find at 3 seconds, if we say that 3 is around about here, we need to draw a tangent at that point just on the curve where the time equals 3 seconds. So I'm going to try and draw a tangent here as best I can on screen. And we want to estimate the gradient of that tangent. There's going to be a bit of leeway here because obviously the tangent will vary slightly, and you need to just pick 2 coordinates on that tangent that you've drawn, and it's wise to choose ones that are whole numbers. So I can see here that that coordinate would be 0, 5, and also this point here is the coordinate 4, 12. And we're going to use these 2 coordinates to find the gradient, which is simply the change in y divided by the change in x. So I'm going to do 12 subtract 5 on the numerator and 4 subtract 0 on the denominator, and that will give me 7 over 4, which will give us an estimate for the acceleration of this athlete at 3 seconds. So we'd say 7 over 4, you could potentially do this as 1 3/4 meters per seconds squared. Now part B is asking us to look at the athlete over the whole 10 seconds, and it's saying that the athlete ran the race in 10 seconds and the area underneath the graph gives the distance the athlete ran in 10 seconds, to show that the race could have been a 100-meter race. So we need to find the area all underneath the curve, and to do this we're going to split it into 2 shapes. The first shape that we'll calculate is that rectangle there, which has a base of 4 because it goes from 6 to 10 seconds, and the height of that is 12. So I'd say that rectangle 1 is 4 times 12, which would be 48 meters, and then we need to calculate the area of the remaining part of the curve. Now there are lots of ways in which you can do this, and if you split this into trapeziums you'll get a more accurate answer, but here we're going to try and make it as simple as possible, and we're going to split it into a triangle and then just 1 trapezium in between, and we should get a good estimate that's quite close to 100. So the triangle 2 has a base of 3 and a height of around 10, I would say. So the triangle 2 will be 3 times 10 base times height divided by 2, and that will give you 15 meters squared. And the trapezium 3 has a height of 10 already shown and a base of 12, and the height, or it looks like the base of this trapezium because it's been rotated, it would be 3. So the formula for a trapezium is half a plus b times h. So we're going to calculate 10 plus 12, which is 22, half that to get 11, and we're going to multiply that by 3 to get 33. So the trapezium of 3 will give you 33, and you'd be given more room than I've been given here to show this. You should be showing how you found that using the formula, and the key that we're looking for is the total. So the total will be found by adding all of those areas together. So we've got 48 plus 33, well 48 plus 3 will give you 51, plus the 30 will give you 81, plus the 15 will give you 96 metres. And that's very close to the 100 metres that they're after. So you're showing that it could have been a 100-metre race, and it makes sense because our estimate's going to be slightly lower. You can see here there's all this missed area underneath the curve that we haven't calculated, and that's going to be equal to probably 4 metres, and that's why our estimate's slightly underneath, but we've demonstrated that we understand that the area underneath a curve shows the distance in a speed time graph, and that it adds up to very close to 100. So it could have been a 100 metre race.